table experts, please report to room A9.
Hello guys, Hector here and welcome to Number Cruncher. This is what the module will look like. You'll have 1 or 2 numbers, and you'll have a operation in the top left hand corner. Oh well, I actually got the same one for both of them. There's a delete button, which you can get rid of what you just typed. The $sign is the submit button. And then there's this help button, which we'll just check. The help button between the 2 layers of tape, the transcript of the current operation on the table here. We saw this recording by pressing the button again. So basically just so it tells you which one it is, basically. Each of these operations is associated with a number of points. Easier operations, such as equality, are lower than more complicated ones like altitude. We're going to amass a total of 20 points to solve the module. So let's just get started. Of course, I won't be able to get through all of these in this one, so afterwards I'll try and explain these as best as I can. So first we have this circle plus, which is exclusive or XOR. For each pair of digits, type the sum modulo 2. So basically,
Cleared. All personnel, please return to your stations.
if their sum is even, we're going to type 0. If their sum is odd, we're going to type 1. So 0 plus 6 is 6, which is 0. 9 plus 2 is 11, which is 1. 9 plus 8, 17, is 1. 8 plus 3, 11, 1. 6, 0. 5, 1. 3, 1. 9, 1. 13, 1. 3, 1. 1, 1. And 11, 1. An easier way to see this is just if they're the same parity, aka 2 odds or 2 evens, it's going to be 0. If it's an odd and even, it's going to be 1. And then we can choose on there's keyboard support. You can also press enter to press the submit button. And also backspace is delete button. But that was correct, so we move on to the next one. We amassed 4 points, as you can see here. Up next, we have plus 1. For each digit, add the number of digits to its left and type with the last digit of the result. So for each digit, add the number of digits to its left, okay. So 7 has no digits to its left, so that's 7. 0 has 1. 0 plus 1 is 1. 1 plus 2 is 3. 5 plus 3 is 8. 9 plus 4 is 3. 6 plus 5 is 11. 4 plus 6 is 10. 1 plus 7 is 8. 8 plus 8 is 16. 8 plus 9 is 17. 2 plus, that's 10 now, isn't it? 1, 2, 3, 4, 5. Yep, 10, so that's just 2. And then 2 plus 11 is 13. And hopefully if we've done that right, we can move on to the next one. So that one's a slightly more difficult one, as you can see. And now a really easy one. Parity, type the digit, modulo 2. So basically, If it's odd, type of 1. If it's even, type of 0. So in this case, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 0, 1. Up next, modulo. For each pair of digits, type the remainder of the first divided by the second. Treat zeros in both numbers as tens. Like we don't actually have any zeros here. So 8 mod 1 is 0. 8 mod 8 is 0. 4 mod 5 is 4. 7 mod 6 is 1. 4 mod 5 is 4. 6 mod 5 is 1. 4 mod 8 is 4. 8 mod 3 is 2. 3 mod 1 is 0. 3 mod 8 is 3. 3 mod 9, 7 mod 9 is 7. And 3 mod 9 is 3. Maximum digit. For each digit, if it's greater than all of its neighbours, type 1, else type 0. 0 is not greater than 5, 0. 5 is not greater than 8, 0. 8 is greater than both 5 and 6, so 1. Meaning the next one's going to be 0. 1 is not greater than its neighbours. The 5 is not greater than both its neighbours. The 5 afterwards isn't either. Nor is a 2. The 9 is. The 2 isn't. The next 2 isn't. And the 7 is. This arrow is going to be reversal. Type the number in reverse. Basically, start from the right and transcribe it from right to left. So it'll be 985 641 341 394. Let's just have a look to make sure you haven't got it wrong. Okay. There we go, so module. Let's do another one. We've got exclusive OR again. So remember, take the sum and then take it modulo 2. Or just if they're the same parity. It's the same parity, which was also something here. The same parity is going to be 0, the opposite parities are going to be 1. Let's do it the other way again here. So 3 becomes 1, 10 becomes 0, 5 becomes 1, 4 becomes 0, 7 becomes 1, 14 becomes 0, 5 becomes 1, 11 becomes 1, 8 becomes 0, 11 becomes 1, 8 becomes 0, and 13 becomes 1. Okay, now we have the x, which you can probably guess, product. For each pair of digits, type the last digit of their product. Pair of digits, of course, being the columns, if I didn't explain that the first time. 8 times 3, 24. Yeah, so 4. 1 times 2 is 2. 1 times 8 is 8. 9 times 2 is 18. So 8. 5 times 4 is 20. 0. 4 times 1 is 4. 7 times 1 is 7. 6 times 4 is 24 as well, I think. Yeah. 9 times 1 is 9. 2 times 4 is 8. 6 times 6 is 36. 8 times 7 is 56, I think. Yeah. Next one, parity, again. So that would be 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0. Okay, we've got altitude now. For each digit, type the last digit of the number of digits it's greater than. So, how many digits is this 7 greater than? We've got 1, 2, 3, 4, 5, 6, 7, 8. 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. And finding out that's going to be the same for the other 7 at the other end. If 3 is greater than 1, 2, 3 digits, this is strictly greater than. We're not counting the same, basically. 8 becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. Because the only one it's not bigger than is the other 8. And we're not including itself, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 3 was 3. The 1 is 1. It's only greater than the 0. 4 is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The 0 is going to be none. The 2 is going to be 2. The 3 was 3. The 5 is going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, yeah. The 8 was 10, so that's 0. And the 7 was 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So hopefully we've done this right. We go on to the next one. A nice easy one afterwards. Reversal. Again, so that's 2, 6, 3, 8, 9, 2, 5, 1, 0, 5, 4, 2. We've got one more. It's this all pointing arrow. It's magnitude. For each digit, if it's 5 or greater, type 1, and if it's not, type 0. So that's 1, 1, 0, 1, 5 is 5 or greater, 0, 1, 1, 1, 1, 1, 0, 0. And we get another module. So of course, like I said, we weren't going to get through all of these. So, maybe I haven't seen all of these, but I'll figure out as much as I can from what they sound like. So let me just quickly mark the ones we already did. I think that's all the ones we did. Okay. Attendance. For each digit, the last digit of the number of times it appears in the number. So for example, if we had 5556666, the attendance of 5 would be 3, because it appears 3 times. Attendance of 6 would be 4, because it appears 4 times. Difference will have 2 numbers, and it'll be the top digit minus the bottom digit, or the bottom digit minus the top digit, whichever one gives the positive result. So basically the absolute value of their difference. Equality is surprisingly more than magnitude. You just typing the number exactly as you see it. Inverse, type 9 minus every digit. So again for this one, that would be 4443333. Lovers. For each pair of digits, type a Manhattan distance from each other on the module's keypad. So if you saw the module's keypad, it looked like this. So for example, if you had 2 and 5, the Manhattan distance is using only orthogonal movements, so up, down, left, right, going from point A to point B. So for 2, 5 or 5, 2, it'll be 1, 2, 3. 1, 2, 3. 1, 2, 3. Manhattan distance also means the smallest distance. Because technically you could go 1, 2, 3, 4, 5, 6, 7. But there's a shorter path you can take to get there, basically. Lunar logic. For each pair of digits, type the highest. So if you've done decimation, it's basically that. The addition in lunar logic is, instead of adding two digits together, you just take whichever one's bigger. Means, for each pair of digits, type their mean, ignoring decimals. This will be two numbers again. The mean of two numbers, if there's sum divided by 2, and then ignore decimals, since it's only going to be 2, it's just basically rounding down. It would have been that for any of them, actually. But in all cases, the decimal will be 0.5. 0.5 or 0.0, technically. Neighbour sum. For each digit, take the last digit of the sum of its neighbours and itself. I think for the bookending ones, so the one at the start and the one at the end, you only take the sum of itself and the one to its right for the first one and left for the last one. You don't wrap back round to the start. Numeric weight. For each pair of digits, type the combined number of ones in their binary representations. So for example, the binary representation of 6 is 110, because it's 4 plus 2 plus no ones. 8 would be 100, 1000. 9 would be 10001. Or 1001, I think I said too many zeros there. 0 would be 0, 1 would be 1, and so on. And you just kind of have how many are in each of the pairs, so again there's going to be 2 numbers there. Pair products, another set of 2 numbers, I think. No, actually this is 1 number. You take, since it's 12, it's going to be pairs of digits like this, and you take their product, and say you had 1, 4, that would be 4. But since we still need it to be 12 digits long, you put a leading 0 onto the front. So rather than 4, you would put 0, 4. Basically 0, 10s and 4. Prime checker. For each pair of digits, their sum is prime, type 1, type 0, this is going to be 2 numbers again. And then the prime number you can get to from summing the 2 numbers will be 2, 3, 5, 7, 11, 13, and 17, I think. Are the only ones you can get to. Yeah. Sorting. Sort the digits of the number 0 to 9. So basically, the amount of times they appear as well. So if you had, let's say, this, the zeros go at the start, and there's 2 of them, and then 1, 1, 1, 2, 1, 4, 1, 5, 1, 9, like that. But you keep the quantity of the amount of numbers when you solve them. Sum. To find digit n of the answer, take the last digit of the sum of the first n digits. So again, there are 12 digits, so the first digit will just be itself. The second digit will be the sum of the first and the second digit. Third digit will be the sum of the first, second, and third digit. Fourth will be first, second, third, fourth, and so on. Thermometer. Start with 1. And for each digit that isn't the first, if it's greater than the digit to its left, type 1. Else type 0. So this will always start with a 1. And then if the digit to its left is bigger than it, you type 0. If it's greater than the digit to its left, so if the digit to its left is smaller, you type 1. Else you type 0. And again, this doesn't count equal to, so equal to is still 0. Triplicity. is basically parity, but with modulo 3 rather than modulo 2. So basically, multiples of 3 will be 0, one more than a multiple of 3 will be 1, and 2 more than a multiple of 3 will be 2. And if I the x sum, for each digit n, take the last digit of the sum of the first n digits in the number. So for each digit n, the first n digits in the number, I'm assuming by n it means the actual value of that number, hence why they had to specify. The sum of 0 digits is 0. So if you had a 0 in the number, you'd be taking the sum of the first 0 digits. The first 0 digits is no digits. So that's going to be 0. So hopefully my explanation for the rest of those was good enough. And hopefully you understand how Number Cruncher works now. And I'll see you guys in the next tutorial. I'll see you later.